Cool. So, multiplayer networking, the high-level multiplayer API. I was getting really confused in Godot because, like in Unity, for instance, there are so many multiplayer tutorials out there. It's crazy. It's very easy to set up. It seemed about as easy in Godot as it could be, and still was giving me a hell of a lot of trouble to make it work. Specifically because the one tutorial that is out there on YouTube is specifically for games that have a synchronized start, and so is the documentation on the Godot website itself. And what I needed, and what I'm supposing many other people will need, is to have a non-synchronized start. So basically my game can already be running and other people can join whenever they join. So I found some example online, and I will quickly find it for you because it'd be nice to give the proper credit for that. I think it was here, or was this it? Let me just quickly read through this. Register player. I think it was this. Yes, I'm pretty sure it was this. So I will link this below as well, so you can have a look through the code. Now this is specific to Godot 2.2, I believe, because there's still some use being made of this set network mode, network mode master, and network mode slave. These things don't work anymore in Godot 3. I don't know if like just the API changed and that has moved somewhere else, or they are using a different way of doing things now. I implemented it differently, so I just want to make sure that this was the same one that I used. I can actually just verify it by this port number. Yes, that's exactly the same. Okay, so I'm gonna run you through my network code. I'm not gonna like recode the whole thing live. We're just gonna run through it, and that should give you a good indication of how to set up your multiplayer. And then if you need synchronized start, then you can I will link to the other tutorial on YouTube here as well, and you can read read the documentation on the Godot website. So first of all, I have just an empty node right here where I attach my network script. I just call it network. So you want to set that up, and then I have my default port, my max pairs, so this is the maximum amount of players that can be connected, and obviously this is the port that we're running on. I mean, I'm not sure if you want me to go into this much detail, but I will. Then we create an empty dictionary called players, and we are going to store our players there. This is gonna become important. And then you can do your player name like this, but in the future, in the next video, I will show you how to set up proper player accounts with we build a little API. I will build that in Ruby on Rails. Build a little API, make HTTP calls to it, so we can get JSON communication going, and then you can store your player accounts and do logins and all that stuff. Okay, so we need to hook up these functions here. So these are all like built-in functions that Godot will call. These are like callbacks, and then you need to pass in the current object, so that's this node, and then connect them to functions. You can call them whatever you want. I called them the same as everybody else seems to be calling them. And then what you need is a start server and a join server function. So start server, I set a player name for server just to be able to give my players different names. And then this is where you really start like a new network multiplayer eNAT object. And in this case, we could just call it host in the variable host. Start this object, and that creates a new high-level multiplayer instantiation, right? And then we do some error checking. Now, I do something a little crazy here. This is fine, create a server, it kind of speaks for itself. What I'm doing here is like if there's an error, because if you already have a server running, so if you start an instance of your game, which is automatically going to become the server, and I'll show you that real quick. I'm going to switch to my main script, and you can see here in the ready function, it will start server, right? So it just calls this start server function. Now, if I start then the second instance to, play multiplayer, it will throw an error saying that the address is already in use. And then I just call join server, so I don't have to like make changes all the time and make new. It's just easier for me to be able to quickly start things. And then don't forget to call a return, because you don't want to get in here, which is where we actually set the network peer. So this is where we actually create a peer on the multiplayer network, right? Okay, and then I call spawn player. I just hard code 1 because the network server is usually always player ID 1, peer ID 1 I should say, peer ID. Okay, so the join server does the similar thing, sets the player name to client, just hard code it for now, creates a new high-level multiplayer object, and then create a client on localhost. This IP address is just your localhost IP address. Obviously that, again, what we will do is here in start server, we will create, like I said, an API in Ruby on Rails. It will have a database table with all servers that are created. Here in start server, we will make an HTTP call to that API and then register that new server in the table, so that when we have a lobby system and everything, we can see all the servers that are created by making an HTTP call here and pulling out all the servers currently running from our API. Okay, so we create a client, for now a local host on the default port, because we have to match the port. And again, we set a network pair for the new player. We are not using this function right now, so just give it a pass. When the player is disconnected, we have to unregister the player. That's a function that we will implement. And we also have to make an RPC call, remote procedure call, to unregister player, so that it is called on every pair on the network. Okay? This is all, like, you can read about this stuff in the documentation. It's relatively easy, right? Like, if you make an RPC call, depending on what you put in front of a remote function, you have a few different things you can do. I only use remote functions at the moment, so that makes it very easy. You can just make an RPC call. This will call it on every other network peer, but I also have to call it locally on my own instance of the game. So that's why I call it twice. Now, if connected is okay, meaning that if I get, as the server, get the signal that somebody's connected, then only on the server do I want to call the user ready function, and I want to get the unique network ID for that pair, so I can do something with that. We will see that in the user ready function in a second, right underneath here. So RPC ID means that you're calling an RPC command, a remote procedure call, on one specific ID. So you're targeting one specific ID to do the remote procedure call on. Okay. So that's actually what I should say is connected OK is actually running on the other player's side. Okay, and it makes an RPC call to me. Let's say that I'm the server. So the player is connected, gets the connected OK signal, sends me an RPC as the server, like, hey, I'm ready, user ready. Okay, so user ready gets the ID and the player name. The ID is the unique network ID that this other player got. And then if I'm the network server, just a little check, then we send that player register in-game RPC call. So now we're sending an RPC call to that player saying register yourself in the game. Okay, so it calls an RPC to register new player with the unique network ID for that player, for the other player, and the player name, okay? And then also for itself, it needs to call that locally as well. So what is happening specifically here is now all the other players on the network are going to get this RPC call and going to respond to that. Server disconnected just calls a quit game function. Yes, register new player, here we are. So this is now being called on all the other nodes on the network so that all of them can get an instance going for this new player. So if I'm the network server, I'm going to call an RPC ID on the other player, the player that is calling me, and say register new player. And I'm going to loop over all the players in the network and send all of them individually a register new player RPC call. Then I'm going to add to the player's dictionary this with the ID of the network peer and his name. So now he's added to the dictionary. So like once we loop over here for the next player, he will be in there. And then we call spawn player, okay? I'm not sure if we still use register player, doesn't seem to be. I think I'm not using this anymore. This is some old experiment, I think. Just to be sure, yes, I'm pretty sure. Alrighty, so unregistered player just gets the node for that that current player that is unregistering, that is like leaving the game, and we erase it from the dictionary. Make sure to use erase because it's a dictionary of objects. Quit game sets the network peer to null and the players to clear, so let's just throw everybody out of the game. Spawn player, which was the one that was called right here, right? Gets the player scene. So the player scene is, I'll show you real quick. Just I put a camera and a cube in there, very simple. And then I will show you one more thing about the player scene, but in a second. And then the player is player scene.instance. So we make an instance of this player scene. We set its name. So that just means like here in the tree, they're going to have a name set to their network ID, which is nice because it's unique, and they have to be unique. And then if my network ID is, if the current ID is the network unique ID, so if it's my player, then, which it should be by the way, but if it's my player, we set the network master on the player. So the player is always the network master of himself, of only his own object, his own instance. I set a player ID variable, so like here in player I have a player ID, and very important, I set control to true. So this I have to show you. You see that like by default I have a control variable that is set to false. And what I do here is like in my process function, consider this to be my movement code, which it is. Like it will go to these things, like my movement code has to go in steps. So it's doing this, but only if control is true. So that means that like I'm not controlling all the other network players. Otherwise, like if one player moves, everybody moves, okay? So that's why only for the ID that is the same, exactly the same as my current network peer ID, we set control to true. and then we add child to the parent. So like the parent will be scene-wise will be here root, and we just add a node to that by using getParent.addChildPlayer. Okay, that's everything you need to asynchronously add players to a game. Okay, now the final thing is movement. And while I do have something weird going on, I don't think it has anything to do with the network code, but it doesn't matter. I'll show you. So, okay. Consider that we are just here. Forget about the rest for a second. Like, step move right here just does basic things, right? Like, you know, if my input key is pressed, this is just a little bit more complicated version of like input key pressed. I'm using arrow keys, so like the IDs are a bit crazy right here, defined. But that all doesn't matter. So like I set up some movement code, like that's all for your game. You do it differently, right? That's not important. And then finally, I end up with a variable that describes my movement as a vector3 right here. Okay, so I have a function called setTranslation. I call that locally because I need to move my own player locally. And then I call RPC unreliable, meaning it's using UDP packets instead of TCP packets, which basically you just think of it like this. TCP packets, they're always verified. It's a three-way handshake. So like you send it out, the server confirms it, and you confirm that, you know, the server confirmed it. It's very slow. UDP, very fast, but you run the risk of losing packets. For movement, it's usually not so bad because you can drop a few packets of movement and it will synchronize again and it should be fine. For now, it's working fine for me. So I have a function called doMove, and I pass in the movement and the current player ID, okay? So setTranslation is just a built-in function. It's just moving my player, but also it's sending this RPC out to all the other players on the network that I'm doing some movement. All doMove does is it gets the root, it gets the current player node by its ID, and then it just takes that node and sets the translation. So what do we end up with? Let me start a server right here, and let me start a client right here. I hope the code is still in sync, but it should be. Let me just make sure that nothing is open. I'm moving my player and right here the box is moving around. It's strangely very slow. This movement should be faster, but for some reason it's very slow and I haven't figured out why yet. Oh, and now it seems to be going fast again. There's something a little icky here, but I will figure it out and then I will show you in the next video about this, what was going on or something. But yeah, that's your basics for like multiplayer. It is really not that complicated once you kind of get the hang of the whole RPC structure. It's basically the same as in any other engine, because the RPCs, that's a tried and true method. It's just that without the documentation is quite sparse when it comes to this, and yeah, I had to kind of figure it out. Luckily, with some help from, you know, the resource I found on GitHub, and then I had to kind of convert it to Godot 3. In any case, like in the description there will be the code to this game. I'm just open sourcing it, so like there will be code there. I will put the link to GitHub there so you can look. The link to the original GitHub file that I found, or project that I found that showed me how to do asynchronous joining of the game. The original Rocketschmeers tutorial on networking, which is also Godot 2.2, so you have to convert, but it's easy. It's pretty easy, and I think that should be it. But if there's anything else, I will put it in the GitHub link as well. thank you for watching, and I'll see you in the next video where we will dive into some other topic or expand on any of these, okay?